In the previous video, we saw how we can find the resultant force of two different forces acting on an angle theta between them. Now we're going to see the reverse process, how we can resolve one force into its components, as we call it. So in this example, we have a force of 60 newtons in this random direction in this case, and we want to find two forces that could potentially create the same effect as the 60 newtons force acting in this direction. So how do we solve problems like this? What I want you to do is imagine two different axes. I want you to imagine the x-axis in this direction and the y-axis in this direction. There is going to be a component of your force F, this is the force F that we want to resolve, on each of these two axes. And you've seen that I've drawn the angle theta, okay, with the x-axis. Usually this angle will be stated in the problem, or you will have to calculate it depending on what other variables you have available. Could be 30 degrees, 45 degrees, and so on and so forth. So what I want you to do in this example is simply draw vertical dashed lines from the end of the vector of 40 newtons towards the x and the y axis, okay, and then let's see how we can translate this into length. So let's call this the Fx because it's the component of the F force on the x-axis, and let's call this the Fy, the component of F on the y-axis. And I hope you can already see the similarities with process that we did in the previous video, which was the reverse process of having the Fy and Fx and trying to calculate the resultant force. So now the goal is that we want to calculate the size of Fx and Fy. And again, the answer is going to be given to us by utilizing some concepts from geometry and trigonometry. So if you focus on this triangle here, and keeping in mind that this length here is Fx, but also that this length here, it's parallel to Fy, so this length is also going to be Fy, the length that goes from the end of Fx all the way upwards. So if we look back into the three trigonometric functions, that the sine of the angle theta is going to be the opposite side over the hypotenuse, or that the cosine of theta is going to be the adjacent over the hypotenuse. And these are functions that you will learn if you haven't learned yet in mathematics. And this SOHCAHTOA TOA is a mnemonic that's supposed to be helping you with remembering the ratios for this sine and cosine. And the last one is for the tangent, which is going to be the opposite side over the adjacent. So with those in mind, if you write down the cosine theta on this triangle, the cosine theta, we said, is the adjacent over the hypotenuse. The adjacent in this triangle to the angle theta is going to be Fx. Okay, the adjacent to theta is going to be this length over here, and the hypotenuse is going to be F. So it's the diagonal on this parallelogram, so it's going to be F. Now, if you solve this one for Fx, then you have that Fx is going to be F times cosine theta. which means if you know F, 40 newtons, times the cosine of the angle that will be given, 30 degrees, 45 degrees, you can calculate the Fx component, as we call it. Now, if you take, let's say that you take the sine theta, which according to SOHCAHTOA TOA is going to be opposite over the hypotenuse, the sine theta is going to be Fy, the opposite from the theta angle is Fy, over the hypotenuse, which is F. And then again, if you solve this one for Fy, it's going to be F times sine theta. So this is the way to split your force, to resolve the one force into its components. And for GCSE and IGCSE level, you will be focusing only on angles 90 degrees, so on two forces that are with have between them an angle of 90 degrees. And what I mean by that is, in the previous example for here that we saw in the video before, so this angle theta was smaller, this angle theta was smaller than 90 degrees, okay, as you can see. It is possible to calculate that as well. There is a formula and everything, which is not the focus for our level. For IGCSE, you will always have two forces like this, and this is going to be 90 degrees, which means you will be always calculating the resultant force in this beautiful and easy way. So you don't have to worry about any angle other than the angle theta being 90 degrees between F1 or F2. So again, I want to draw your attention on the trigonometric functions, which hopefully you've seen already in math. If not, use this mnemonic here to help you. And utilizing this tool, it's quite easy to calculate the two components of the resultant force. I hope you found the video helpful.